Hi friends, this is Meera and welcome to my channel. Today we will discuss how to find centroid of area of a C-section or channel section. In this video, I am going to give you step-by-step procedure to solve numerical of centroid and a tip to solve this particular type of examples very quickly in last section of the video. So keep watching till the end. You can go through my video on basic concepts of center of gravity and centroid for better understanding of concepts before we start solving numerical. You can find the video in I button above or a link in the description box below. So let's begin. Suppose we are designing a warehouse made up of different steel sections. It is the same warehouse whose centroid of I section we calculated previously. Here, the bottom chord is made up of channel sections and we want to find out the centroid of its cross-sectional area. Let's say some of the dimensions of this section are known to us, like top flange is 15 cm by 4 cm, bottom flange is also 15 cm by 4 cm, web thickness is 5 cm and overall depth is 20 cm. Now, the very first step is to locate the dimensions and reference axis and find out all missing dimensions. Place x-axis at the bottommost plane of section and y-axis at the leftmost section. We will show all dimensions on the cross section itself for convenience. Top flange is 15 cm by 4 cm, which means that width of this flange is 15 cm and height is 4 cm. Similarly, width of bottom flange is 15 cm and height is 4 cm. Web thickness is 5 cm and overall depth is 20 cm. Now check for any missing data of width or height. Here only one dimension is missing and that is height of web. We can find it out by subtracting upper and lower flange height from overall depth. That is, overall depth of 20 cm minus 4 cm of top flange minus 4 cm of bottom flange equals to 12 cm. Next step is to divide the whole area into more basic shapes whose centroid locations are known to us. Centroid of some shapes are given in reference books like triangle, rectangle, semicircle, quarter circle, etc. You can directly memorize this and use in numerical to avoid tedious and lengthy calculations. For this problem, we will divide it into rectangles. You can divide the area as per your convenience like this or this. Try it yourself for both divisions and you will see that centroid coordinates are same in each case. Here we will pick any of these two divisions and find out centroid in following steps. Generally try to divide shape so that at least one axis is touching as many divisions as possible. Like here, y-axis is touching all divisions 1, 2 and 3. It will make calculations easier. Next one is an important step where all required data will be calculated. Before we start calculations, let me quickly remind you the equations to find out x coordinate and y coordinate of centroid. X coordinate is equals to sigma ai xi divided by total area and y coordinate is sigma ai yi divided by total area. So to find out centroid, we'll have to find out area, x coordinate and y coordinate of all the individual divisions denoted by I. In our case, there are 3 divisions and all of them are rectangles. So in general, area of rectangle is width multiplied by depth and centroid coordinates are b by 2 and d by 2 depending on the position of rectangle. Also, all dimensions are in centimeter. So unit of area will be centimeter square and unit of x and y coordinates will be centimeter. Now let's find it out for rectangle number 1 or the bottom flange. Right now we will just focus on bottom flange and ignore other two rectangles. Locate centroid and dimensions of rectangle 1. Now area of rectangle 1 is 15 cm width multiplied by 4 cm height, that is 60 cm square. The most important step is to find out x and y coordinates of individual shapes. If you know how to find it correctly, problem of centroid is very easy to solve. So now, as we know, centroid coordinates of rectangle are width by 2 and height by 2. X coordinate of rectangle 1 is dimension in x direction, which is 15 divided by 2, that is 7.5 cm. And y coordinate is dimension in y direction, which is 4 divided by 2, that is 2 cm. Now check out the location of reference axis with respect to the selected rectangle. As per reference figure, both x and y axis should touch the planes of rectangle. Here in our case, both axes are touching the plane. So final coordinates will be same as previously calculated data and no alterations needed. We will repeat step number 3 for other two rectangles. So first we will highlight rectangle 2 and locate centroid and dimensions. Now area of rectangle 2 is 5 cm width into 12 cm height, which is equals to 60 cm square. X and y coordinates for rectangle in general are width by 2, that is 5 by 2 is equals to 2.5 cm, and height divided by 2, that is 12 by 2 is equals to 6 cm. But this method can be applied only if reference axis is placed at this location. But it is not the case. Y-axis is touching the plane of rectangle 2, but location of x-axis is some distance away. So a little change in coordinates will be necessary. So to find out y coordinate, we have to add this distance from reference axis to the previously found coordinates of shape. This distance is same as height of rectangle 1, that is 4 cm. Now area is same. Final x coordinate x2 will be same, 2.5 cm, and y coordinate y2 will be 6 cm plus 4 cm equals to 10 cm. Now repeat step number 3 for rectangle 3 or top flange again. Highlight rectangle 3 and locate centroid and dimensions. Now area of rectangle 3 is same as rectangle 1, that is 15 cm width into 4 cm height, which is equals to 60 cm square. To find out x and y coordinates in general, coordinates are width by 2, that is 15 by 2 is equals to 7.5 cm, and height by 2, that is 4 by 2 is equals to 2 cm. Again, these individual coordinates of rectangle are for this location of x and y axis. Here also y axis is touching the plane of rectangle, but x axis is some distance away. So we have to add this extra distance to previously found y coordinate of shape. This distance from x-axis we can find out by adding heights of rectangle 1 and rectangle 2, which is 4 cm plus 12 cm equals to 16 cm. Now again area is same. Final x coordinate x3 will be same as x, that is 7.5 centimeter as y-axis is touching the plane, and y coordinate y3 will be 2 plus 16 equals to 18 centimeter. Last step is to sum up all the data we have just calculated. We just need to input area, x and y coordinates results in the equation of centroid of an area. So to find out x coordinate of centroid, we will take moment of area with respect to y-axis. So total area moment will be equal to summation of moment of all individual areas. Or you can memorize this equation directly. Put all values of a1, a2, a3 and x1, x2, x3 and we will get x coordinate equals to 5.83 centimeter. Similarly, y coordinate of centroid can be found out by taking moment of area with respect to x-axis. So, moment of total area will be equal to summation of moment of all individual areas. Put values of a1, a2, a3 and y1, y2, y3 in this equation. So, y coordinate we get is 10 centimeter. If we place a line parallel to y-axis and rotate half a part of channel, you will observe that both parts are not similar in shape or dimension. Thus, our channel section is not symmetric about y-axis. But if we place the line parallel to x-axis and rotate half part, both parts overlap. Therefore, our C section is symmetric about x-axis. So to solve the example quickly, take x-axis at middle point so that y coordinate will be 0 and just find out x coordinate using above method.